The catalyst for treating acid mine water in mining operations, and it seems that it's quite a naturally occurring problem from the exposure of sulfide bearing rocks to oxygen and water, forming a sulfuric acid or H2SO4. And this is problematic for a lot of mines because you can't discharge this into creeks and rivers because it's quite dangerous to marine life. And of course, if you use it for washing vehicles, they'll go rusty. And of course, if you put it out in the lawn or plants at the pH at 2.1, it will kill the grass or any plants it comes in contact with. So it's problematic, and a lot of mining companies have looked at alternatives like using reverse osmosis or spray evaporation, which are very expensive processes compared to what we have. I've got a little bit of water from, we're treating some water at an abandoned copper mine up in the Northern Territory called Red Bank Copper. And I just like to give a little demonstration of what this is. And that's the water from up there at Red Bank. And as you can see, it's got a slightly blue tinge to it because they were using heap leach extraction with sulfuric acid to make this. But this pit's 650 metres long, and it's overflowed in the wet season and destroyed all the fish in the Hanrahan Creek all the way to the Gulf of Carpentaria. But when we apply our catalyst to it, watch what happens. You can see it's changed colour. And the reason it's changed colour, all the copper that was dissolved in that water has now come out of solution, and it is recoverable. Matter of fact, in this particular one, when you dry that out, it actually gives you a powder like that, and you can see from the blue that that's actually copper sulfate decahydrate. But with that, the copper sulfate, after we treat it, is in a recoverable form of copper oxide, and that at the Red Bank Copper one, at 5 grams, and that's your dry weight of this per litre, represented $29 million worth of dissolved copper in their water. Now the beauty of this solution is that we've tried it on gold mines, copper mines, even the old Mount Morgan, and it works perfectly on all of these, where by removing those minerals, and on this one particular gold mine, we pulled out 32 grams of dissolved or dry matter per litre of water. Now we don't know what it was, but there was something in that water which is probably recoverable. But the point with this, it makes that water on top there safe for the environment. And we used to demonstrate by putting a fish in the water, which proves us, how safe that water is to dump into the environment. But it's a very, very low cost method, and I'll give you a little example. And I won't mention the mine, but there's a mine not too far from here who've got 7 really large pits, and they've got 13 diesel powered pumps there to pump water to 158 spray evaporators, and they evaporate about 100,000 litres a day through this infrastructure at a cost of $56,000, but they're only evaporating 100,000 litres. Now we can treat that same 100,000 litres for less than $3,000, and it's a very, very low cost alternative because all you need is a pump to pump the water out of the pit into a shallow pond, right? And that's an earthen pond normally constructed about 100 metres by 10 metres wide, about a metre deep, which will hold 1 million litres of water. So you can pump out 1 million litres a day. You inject our solution into the suction side of the pump, which mixes as it goes through the pump, and the settling pond, you'll see that exact effect there. All the minerals settle out of the water. So, and the water on top now is suitable for discharge to a river or creek or environment, or particularly for washing vehicles or utility water around the mines.